Hey kids, welcome to lesson 8.2, enhanced for each loops for 2D arrays. Since 2D arrays are really arrays of arrays, you can also use a nested enhanced for loop to loop through all of the elements in an array. We loop through each of the inner arrays and loop through all the values in each inner array. Notice the type of the outer loop array variable. It is an array that will hold on each row. And kids, this is just the visual for the saying an array of an array. And hopefully you've seen that animation. If not, maybe I'll make it pop up here. We have a nested enhanced for loop. We have our method getAverage. It is an integer array that is A. We're also creating a variable total, which is a double. It's currently set to 0. We have our enhanced for loop, outer and inner. We are creating another integer inner array, and it's going to look through A. Our inner array is going to create another variable value, and it's going to look through inner array, which we created above. Our total is going to equal our total plus the value. So we're going to keep adding to the value as we keep going along. Our return here is the total from above, the length of the row, and remember, to get the length of the column, we use this square bracket 0 index because we're assuming whatever the column length is there, it is for all of them. So that's how we print that off there. Down here, it looks like we have 2 rows, 3 columns, and some scores, and we're going to print off that array of those numbers. We should get some number. Let's hit save and run. There is our average of these numbers right here. And if we change those to 85, maybe 90, you can see we get a different average. So it's always going to be looking through these arrays just like it was before. And just like our enhanced for loops from the previous units, we're creating a new variable looking through the array. Then we're creating another variable to look through the inner array, and that's looking through the inner array variable because it's an array of arrays, kids. In this case, for this line of code, this means to loop through each element of the outer array, which is set to the array variable to the current column array. Then you loop through the value in the column array. That means you go through the row, all the columns, row, all the columns. All of the array algorithms can be applied to 2D arrays too. For example, counting and searching algorithms work very, very similar. The following code adds all the values in a given row. What will the following code print out? Can you complete the method getTotal for col that will get the total for a column? To do this, you must loop through the rows. The array's length will tell you how many rows you have since it is an array of arrays, while the length of the array's first element will tell you how many columns. Let's take a look at our code here. We have a method getTotal for row. It is creating a variable total set to 0. We have an integer column, which is set to 0 as long as it's the length of the column. We're going to keep going through. And the total is going to equal the total of whatever A is at that row and column. We're going to return total. This looks like the method we have to complete here. So if you look, looks very similar to this one up here. Integer row, creating an integer array. And this looks like column, creating another one, A. Down here, it looks like we have some numbers we're testing. We'll see what that matrix means here in a minute, kids. And what do we have to do here? Well, gives us a pretty big hint up there, kids. We pretty much have to do the same thing, but instead of for a column, we're going to do it for a row. That means for, we're going to take another new variable. This one's going to be called a row. While it's equal to 0, we're going to progress through it. And row is less than a dot length. We don't need the index 0 because we're going through the row this time. And then we're just going to progress up row plus plus. And then we're going to have to add our totals. And our total is going to equal total plus a row and column. Then we should return the total. Should be getting, I assume, how many numbers are in there. Let's see what happens. Six and 5. What this is giving us is what the totals are at 0. That means the row at 0, that's going to go 1, 2, 3. If you add that up, that's 6. If we go the column 0 down, 4 plus 1, that's 5. We can test our hypothesis here. If we add to this number 5, hit save and run, this time we should get 5, 6, 7, 8, 9, and then 9 printing down. Oh, looks like my math was a little wrong here, kids. 5, 6, 7, 8, 9, 10. Oops. 10, and then 9 down. So that's all that matrix is giving us, is just whatever the answer to that total is. Just keep that in mind, kids. You can loop through just part of a 2D array. You can change the starting value and ending value to loop through a subset of a 2D array. And let's take a look at this code here. And it looks like we have a method count values. It is creating an integer value, an int array A, and then row start, row end, column start, column end. Looks like we are looping through here. We have a count equal to 0, row start, as long as we're going through the row, as long as it is less than row end, it's going to keep going. Same with column start. Looks like if the row and the column equal the value, we're going to add 1 to the count and then return. So it's just looking for the same value of whatever these two are added up to. Well, then looks like we have a matrix here with a bunch of numbers, and then we're printing off here matrix 3, matrix 0, 2, 0, 2. Wonder what's going to happen. Let's hit save and run. We're getting 4. So to understand what's happening here, we have to understand what's being asked right here. We have a bunch of numbers, kids. And the first number is going to be the value we're looking for. So this is going to be the value up here. This is going to be the matrix we're looking through, or the array. This is going to be row start, row end. So we're going to start at 0, 0, 1, 2, and we're also going to end at column 0, 2, 0, 1, 2. So this is going to only look through this set of numbers here. In that instance, we have 1, 2, 3, 4 3s. So you have to understand what it's searching through to understand what it's getting here. And we could change the number 4 now. And we should get the value of 1. And if we go back to 3, and if we go to 0, 3, 0, 3, now we should get these other 2 3s here. Woo! I'm getting an out of bounds error, kids. That's because you can't increase the columns. It's still the same number. We just increased the rows. Now we get 6, 1, 2, 3, 4, 5, 6. So again, kids, you have to understand the correlation between these two to understand the number you're getting there. Here's a linear search algorithm where we can access each row and then apply a linear search on it to find an element. What will the following code print? Can you change the code to work for a 2D string array instead of an integer array? Note that the indices row and column will still be an ints. This is a big hint on this one, kids. Taking a look at our code here, we have a Boolean search, and it is an array, and it's also an integer value. We're returning a Boolean here, true or false. It's searching through the rows and the columns. If the row and column equal the value, then we're going to return true. Down here, we have our array. We have 1, 2, 3, 4 rows here to look through. It's going to look through the number 10 and the number 11. We should get 1 true, 1 false, because the value 10 will equal the row here once. Let's see if I'm right. And that's related up here to the array and the value. Let's see if we get true and false. True and false. Now we have to change this for a string, kids. That means we have to change the type of array and the type of value we're looking for. If we go down here, we're going to comment this out, and uncomment this. And I think, well, there's one thing up here I didn't change. And kids, remember, in data types, we can use the equal, but when we're using strings, we have to use the dot equal, and then we're going to need some extra parentheses here to check for a value, because equal is for data types alone. Let's go ahead. We should get 1 true here. Oh. Dot equals, kids. And we got 1 true. We can test this by coming down here, and let's test for an R, an uppercase R. And let's do a case sensitive one too, kids. Let's do a capital A, and we should get true, false, false now. And our code's just looking through. So that's an example of a linear search using a 2D array. Again, kids, I'd memorize this because I am positive you're going to see this on the exam. We have our programming challenge. Photographs and images are made up of a 2D array of pixels, which are tiny picture elements that color in the image. The color of a pixel is represented using the RGB, red, green, blue color model, which stores values for red, green, and blue, each ranging from 0 to 255. You can make any color by mixing these values. And you can try this RGB color mixer here, kids. We're not going to do it in this video. Can you make black? Can you make white? One of them's the absence of all color. One of them's all the colors all thrown together. Can you make purple? Scroll down to the bottom of the following code and take a look at zero blue method. Run the code and watch what it does. It uses nested loops to visit each pixel in a photo which has a color red, green, and blue, and then sets all of the blue values to 0. Now, write a similar method called keep only blue that visits every pixel and sets the red and green values to 0, but does not change the blue ones. Then write a method called switch colors that swaps the red pixels and the green pixels or the blue pixels to change the colors around. We're going to need to use the get red, get green, get blue to get the RGB values of a pixel and then swap them around using a set red, set green, set blue methods and give them different color values from the get methods as an argument. This one we're going to need to use the get and set methods. You can test the methods in the active code below or going to Replit. We are going to do this here in Runestone, kids, but you can use the Replit link if you want. So what do we have to do? We have to write a method keep blue only that keeps only the blue values by setting the red green values to 0. Uncomment the code to test it. And then we're going to write a method called switch colors that replaces the red using the pSetRed with green or blue values using the pSetGreen, etc., to change the colors around. Uncomment the code to test it. And then it looks like we have 2 more methods. We'll get to those in a minute. Let's take care of our first 2 first. We're importing a bunch of stuff here, kids, and a bunch of shout outs to the people who really put this together. Much smarter people than me, kids. We have our public class picture. Looks like we're making a constructor takes no arguments here. And it has a child constructor called super, which is going to call the parent constructor. We have picture, which is creating a file name. Then we have another one, picture, which is height and width. And super is returning width and height. Then we have another picture, which is picture copy picture. And another super creating a picture. This is getting our images. We have our toString method, which is pulling the picture file name and then the width and the height for our output. Here's our 0 blue method that we're supposed to take a look at. And you can see it is a for loop and it's an enhanced one. Looks like it's looking through each one of the rows and columns. And it's setting the ones to blue to 0. We have to do one that's called a keep only blue. And you can see it's going to set the remainder other 2 to 0, but keep the blue ones. What's that going to look like? Well, much like above, kids, we're going to do a public. And we got to make sure we're not in the comment section here. And this one's going to be public void. And we're going to call this one keep only blue, like that. And we're going to come down here, one curly Q. And this one is going to be looking through the same array. So we're going to do pixel, rows and columns. This is going to be pixels. And this is going to equal this, get pixels. Make sure we spell that right. We'll double check that here in a second. Now that we're creating our array, we have to look through it. So we're looking through the pixels. And we're going to do the row. Which array? Well, the pixels array. And then that's the outer loop. We have to do the inner loop now, the for. We got to create another one, pixel P. And that's going to be the row array, like above. Now we have to set our colors. And this time we're just going to do P set red to 0 and P set green to 0. Just like that. And then 2 curly cues to end our for and our main method. This should print off one that is just blue. We go down here. We have to do our keep only blue ones. We have to start uncommenting some of these out. So you can see keep only blue, and we have keep only blue being called down here. So we have to uncomment this to test it. And it looks like they're providing us for the next one, but I think the final 2 is going to be on us, kids. And all this is doing is just printing off our new object that we're creating here, which is a new arch picture, just keeping only the blue, and this one has 0 blue. So we should get 2 pictures, one with a lot of blue, one with no blue. Let's see if I'm right, kids. We got an error. Let's go to our line 110 and look at this. Whoop, if you look here, I got an extra bracket, kids. Be careful, they blend in. I think that is our only error. Let's run it and see our 2 pictures. And you can see we have our original 2, and then they keep only blue. Again, if you look down here, we are printing off 2 of these images. You can see in the original one, they're showing the original with blue, and then we are showing it only with the other one. So that's why we're ending up with 3 pictures, and we're getting the print off keep only blue here. In this one, we're getting no print off whatsoever. Just keep that in mind, kids. That's why we have 3 prints, but only 2 calls. Well, that's 2 done, kids. The next one I have to do here is to switch colors. And I think this one's going to be very similar to this one, except I'm going to create a variable that I can swap out to switch the colors around. So maybe I could set red to green, green to blue, and everything just gets changed. Let's try that out. This is going to be my switch method here. And we're going to start the same way. We have our public void switch colors like that. So that creates it. 1 curly Q. We're going to do pixel, watch your brackets. Brackets, we're creating a new pixels. This is going to be equal to this, get pixel to D. And then we need our loop. Loop is going to be the same thing. We can stretch this out so we can copy it. It's going to be for. And on this one, it's going to be just like above, pixel, and then row array, pixels, and then another curly Q, and then another for loop, pixel P, row array. Like that. Then we can start creating our variables. Now, before we create our variables down here, we have to declare them. And I'm just going to make it simple. I'm going to do int red, int green, int blue, just like that. Now down here, I can set red to p.getRed from our instructions above kids, like this. And I can do the same thing for green. So green p.getGreen. And then blue is going to equal p.getBlue, like that. Now we can just mix them up, kids. p.setRed. Well, above we were setting that to 0, right? Well, this time we can just set it to green, like that. And then we can p.setGreen to maybe blue. And then maybe p.setBlue to red, like that. Then we need 3 curly cues to end this. And that should look through each of the pixels. And then I'm setting the pixels to a variable and then flipping them around. Now, if I go down here, I need to uncomment the third one here, which is switch colors. I should get another picture here with the colors all flip-flopped. Let's see what happens, kids. Uh-oh. Looks like I made an error here. And I got the wrong colon. Let's hit save and run. Looks like we have one more spelling error. That's why you should take time and read it first, kids. And we just forgot the S there. Should be pixels. Let's try again. And now our switch colors. Starting to look like an Instagram filter there, kids. Pretty neat. That showed us how to set different colors, even how to switch it. And down here, we have 2 more things to do. So we're going to write a negate method to negate all the pixels in a picture. To negate a picture, set all the red values to 255 minus the current red value. The green value to 255 minus the current green value. And then blue value minus 255 is the current blue value. Then we're going to do a grayscale. And the grayscale is going to set red, green, and blue values to the average of the current red, green, blue values. And we get that by adding the values and then dividing them by 3. And this is very important, kids. You have to add all the 3 values and divide by 3. So it's much like the ones above when we were adding up the averages. So keep that in mind. Well, that's why we're going over it. Well, let's go ahead and start this one off here. And I'm going to find where I was writing at there. There's my switch method. Let's add our negate method here. And kids, we're going to be doing a lot like what we were doing above. So public void, and this one's going to be called negate. And we're going to need a curly Q, and then pixel, bracket, bracket, pixels, and then equal this dot get pixels 2D, parentheses, and your semicolon. We're going to have to create variables again because we're going to be doing essentially the same thing. So int red, int green, int blue. Now we have to create our for loop for pixel, and then we're doing our row, and that's row array And then we're doing pixels array. And then our inner loop for pixel p, we're going to do row array. And then this is where we got to do some thinking, kids. So this one again was setting 255 minus the current value. We can do something like we did above here. And that is set the current value, and then instead of switching it, we can just subtract it from its regular value. That means we can essentially just come up here, copy and paste this right down here. And then we're just going to do set red to 255 minus red, just like that. And then p set green, that's going to be 255 minus green. And then blue, 255. Like that. We have 3 curly cues and the 4 and the method. And that should, minus some spelling errors, negate the pixels for each of those colors. Now we still got to write a test for it, kids. So we're going to come down here, and this is going to be our negate test. And we're essentially going to write just like above. It's going to be from picture. And let's give us a little room here so we can see. And this is going to be picture arc4. So we're going to do a new object here. And this is getting the picture arch JPEG. And then we're going to print off the negate colors like that. And then we're doing arch 4, and then we're calling the method from above, which is negate. And then we have to show the picture. Don't forget your 2 curly cues here, like that. Now I should get all of the colors negated. Let's see if I'm right. Oh, looks like we had a spelling error here. Oh, no error here, kids. There shouldn't be any curly cues. They should be at the end. Yeah, that's spelled right. Looks like we do have a 1 spelling error, though. 147. That should be a capital P. Save and run. I think we got them all now, kids. And now you can see we get a kind of negative effect from negating all of the colors. Pretty neat, kids. One last one to do. That's Grayscale. Let's go down here. Comment it out. This is going to be a Grayscale. And let's look above so we can see what we're looking at here. Same thing. I'm going to do my public void, and this is going to be called Grayscale, like that. Curly Q. We're going to do pixel bracket bracket pixels equal this dot get pixels to D, and our parentheses. We have to make our variables again, int red, int green, and int blue. We have to do our loop for pixel in the row array. And then we're doing which one? Pixels. Curly Q for pixel P. We're going to do the row array. Now we're going to pretty much do the same thing here. So I'm going to copy this one. Don't forget your curly Q on that. Put that there. Now, if you remember, this added the 3 values and divided by 3. So this time, P set red is just going to be red plus green plus blue. Then we're going to divide it by 3. P set red, and we need another parenthesis here because we want to do red plus green plus blue. And then we're going to divide that by 3. That should be adding the 3 values up and dividing by 3 should give us only gray colors. Let's do P set green and the same thing. And we can copy and paste this part because it's going to be the same for both of those. And then P set blue is going to do the same. Don't forget our 3 curly Qs. And that ends that one. Now we have to create one more test here. And remember from last time, the curly Qs go after all of the tests. So we're going to do picture arch 5, which is going to equal new picture. That's going to be the arch JPEG. And this is going to be a system out print ln. And this is going to be Grayscale. What do we want to print off? Well, our new object here, arch 5, and that is Grayscale. Make sure this is printed exactly like above, kids. You're calling that object 5 show. And that should print us off a 5th picture. Let's see. Well, let's comment this out here too, kids. This is our Grayscale. Now, when I hit save and run, if there's no spelling errors. Whoop, we had a spelling error. Looks like we used the wrong colon, kids. Looks like we forgot. Didn't we copy and paste that? That's the problem with copying and pasting, kids. Forgot something there. Now we get a grayscale picture. How fun is that? Well, that's how we use a 2D array to look through a series of rows and columns, which are arrays of arrays, and change the values. So it's a pretty neat little way of demonstrating a linear search algorithm, kids, and probably something you're going to need to know on the test. Those complete those 2 things, and this goes along with the picture lab from the AP CSA exam. We have a summary here. You can loop through 2D arrays using nested for loops or nested enhance for each loops. The outer loop for a 2D array usually traverses the rows, while the inner loop traverses the columns in a single row. The 2D array's length gives a number of rows. A row's length Array index 0 length gives you the number of columns. Nested iteration statements can be written to traverse the 2D array in row major order or column major order. And remember, we just switched the inner and outer loop. In an enhanced for each loop, the variable the outer loop must be the type of each row, which is a 1D array. The inner enhanced for loop variable must be the same type as the elements stored in the array. All the standard 1D algorithms can be applied to 2D array objects. When applying sequential linear search algorithms to 2D arrays, each row must be accessed, then sequentially or linear search applied to each row of the 2D array. Array of array kids. And that finishes up Unit 8. The next couple of lessons are all review. And we're going to do one FRQ on 2D arrays. Then we move on to Unit 9, kids. There is an awesome little game down here to play that'll help you strengthen your 2D arrays. We're not going to cover it in this video, kids, but again, awesome little game to help you practice 2D arrays. And that's it for this video, kids. Hopefully you found it helpful. As always, if you have any questions, let me know. Otherwise, I'll see you on the next video. See you later, kids. Bye. Bye.